One letter linear equation like we did way back at the beginning of this series. We subtract 3 from both sides and we get x equals 13. And if we check, plug the 13 back in, 13 plus 3 is 16. The square root of 16 is 4, so it checks. An important thing to remember is when we have a square root in an equation, we're always talking about the positive square root, or if it's the square root of 0, obviously 0. If when we're solving an equation, as we did with quadratics, we take the square roots of both sides, so we have like x squared equals 16, we take the square root of both sides, we get x equals plus or minus 4. But for example, in the problem we just did here, when we took the, when we squared, we simply said that's 16. We went back over here to check. When we said the square root of 16 was not plus or minus 4 because that's part of the equation. Only when we're actually taking the square root of both sides of an equation do we worry about the plus or minus. Hopefully you understand that difference. Let's look at a little bit more complicated equation in our first visual. The square root of x plus 3 equals x plus 3. Now think about what that means. What that means is the square root of some number is equal to the number itself. You may say, I don't think that can occur. Well, let's find out, because remember, there are equations where the answer is there is no answer. In fact, I think we'll run into one fairly soon. What did I do here? Well, in the second line, which is highlighted, we squared both sides. And again, x plus 3 squared does not mean x squared plus 9. It means x plus 3 times x plus 3, which is x squared plus 6x plus 9. We are now solving a quadratic equation. It keeps coming back to us. What do? We get everything on one side equal to 0. That's highlighted on line 3. We factor the quadratic and set each factor equal to 0. And thus we get our solution as shown in the last line, x equals negative 3 or x equals negative 2. Of course, we need to check. So let's go to the next visual where we check. First, we'll check x equals negative 3. We replace the x with negative 3, solve the equation. Of course, we get the square root of 0 equals 0, and that checks. We then replace x with negative 2. And we wind up with the square root of 1 equals 1, and that checks. So therefore, both answers, negative 3 and negative 2, are answers to this square root equation. Let's take a look at the next visual and another square root equation. This equation looks very similar. That is, you have a square root equal to a linear term. The square root of x minus 3 equals x minus 5. We square both sides. We have a quadratic. We move everything to the left side, and we get quadratic equal to 0. We factor, set each factor equal to 0, and as seen in the last line, we get the solution x equals 4 or x equals 7. In the next visual, we show the check of these two solutions. The square root of 4 minus 3, again, we replaced x with 4, which is 1, equals 4 minus 5. But wait a second. 4 minus 5 is negative 1. Does 1 equal negative 1? No, it does not. X equals 4 is not a solution to the original equation. And ever since we began solving equations in this series, I've always said check in the original equation. X equals 4 was a solution to the quadratic, but not to the original equation. And that happens quite often in square root equations. We then check x equals 7. The square root of 4 equals 2, as seen in the second line on the visual, and x equals 7 is the only solution to our square root equation. Let's take a look at another one, again with a little different wrinkle in it. The next visual shows us a square root equation where we now have something added outside the square root, and we've even multiplied the square root by, in this case, 2. Well, what do? Again, we isolate the square root first, which is what we've done. On the second line, we have subtracted 19 from both sides. On the third line, which is highlighted, we have divided by 2 to get to a square root equation that says the square root of x minus 5 equals negative 7. What do we then do? Well, the next visual shows us what to do. We continue on. We square both sides. Notice negative 7 squared is positive 49. We then solve for x. We get x equals 54. We then check our only solution, which is x equals 54. We replace the x with 54, and we get 2 times 7, which is 14, plus 19 equals 5. Now, I don't know how bad your arithmetic is, but I don't think that 14 plus 19 equals 5 in anybody's world, and therefore that x equals 54 does not check. In fact, the answer to our original equation is that there is no answer, or no solution. All right. We've looked at various types of square root equations, and as before, we generally use our knowledge of solving equations to help us sketch graphs. Because remember, the word graph means picture, and in my mind, when we start building models using functions to explain real-world phenomena, to predict what's going to happen in real-world situations, we need to be able to picture that, and therefore a graph is worth the old 1,000 words. And to sketch or draw that graph, we need to know something about solving equations. So what we're going to look at now is sketching square root equations, or if you will, square root functions. Let's go to the easel and take a look at the very basic square root equation. Okay. Let's have y equals the square root of x. And since we, at this point in time, may not know a whole lot about this equation, let's just plot some points. One thing it's important to understand is that x cannot be negative, because we have no imaginary locations here for our y-axis. We can't plot the point x equals -4, y equals 2i. So therefore, x can be 0 or positive. When x is 0, y is the square root of 0, and that is 0, 0, which is a point right there. When x is 1, y is the square root of 1, and that is 1, right? So we'll plug 1, 1. I'm going to use 2 boxes here. I don't know if you can see these blue boxes. I'm going to use those boxes. 2 boxes equals 1, just to expand our picture. All right, then let's see. We could put in 2, but many people don't walk around with the knowledge of the square root of 2 in their heads. So let's pick another square number that we can take the square root of. How about 4? Let's see. 1, 2, 3, 4. There's x equals 4. And the square root of 4 is 2. So that goes up here. And you can kind of see what's happening. To get to a y of 3, we're going to have to go out to an x of 9. And therefore, we get a graph that looks like this. It's curved, but it really is, as we go here, it starts to settle down, and it rises, but slower and slower and slower. And there are many things in the real world that do that. Increase very rapidly at first, sort of level off, and keep increasing, but increase at a slower and slower rate. By the way, if you turn your head sideways, you might notice that this looks kind of like 1/2 of a parabola. And it should, because y equals the square root of x is the inverse function of y equals x squared. So that the fact that it looks like a parabola makes a whole lot of sense. The key thing we want to take away from this sketch is this endpoint. In square root equations, in graphing square root equations, there appears to be an endpoint, and the reason is whatever's inside that square root cannot be less than 0. So what we're going to do is to find that endpoint is solve what's inside the square root for 0. Here it was easy. X equals 0, so x equals 0, and plot the point, knowing that should be the endpoint of our sketch. Okay, it says here the next thing we need to do is to take a look at a square root function a little more complicated than the square root of x. So our next visual shows us that we have y equals the square root of x plus 4 minus 3. Again, and I hope you're used to this by now, we're going to go through a step-by-step process to graph these functions. And the first thing we've always done is look for the y-intercept. The y-intercept for square root functions is no different than the y-intercept for any other kind of function. It's simply where x is 0. When x is 0, y is -1. That is the square root of 4, which is 2, minus 3 is -1. Then we look for the x-intercept or x-intercepts. In this case, as in all cases, the x-intercepts occur when we set the function equal to 0. It's the values of x that make the function 0. So this is why we had to be able to solve square root equations. So back to the visual on the line there at the x-intercept, we take the equation, the square root of x plus 4 minus 3, set it equal to 0. Now we need to solve that. The next visual we do that. In the next visual we've solved the square root of x plus 4 equals 3. We square both sides and we get eventually x equals 5. And at the bottom of that visual we can see we've plotted 2 points. We've plotted the y-intercept 0, negative 1. We've plotted the x-intercept 5, 0. That's just 2 points. We need a third point, and that third point is going to be our endpoint. Remember from the easel, we saw that what's inside the square root can be no less than 0. So in the next visual, we seek out the endpoint. We take the square root and we set it equal to 0. And we solve for x and we get negative 4. We replace x in the original equation with negative 4. And we get y equals the square root of 0 minus 3. So when x is negative 4, y is negative 3. That is our endpoint. Or you might say the beginning point. And we know what this square root should look like. It should look like half a parabola laying on its side. So the next visual shows us the third point, the endpoint sketched or plotted, and then the sketch of the curve that begins at the endpoint and goes through the y-intercept and then the x-intercept and continues out. Notice the curvature. Notice again, if you turn your head sideways, you can see it looks like one side of a parabola. Okay, let's take a look at